As we continue to look at triangle proofs, we bring up another idea of saying that corresponding parts of congruent triangles are congruent, or CPCTC. So far we've done triangle proofs where we've gotten to this point of showing triangles that are congruent. And as we first talked about whenever we did triangle congruence, is if the triangles are congruent, then all of those corresponding parts, 3 sets of sides and 3 sets of angles, will also match. So we're going to use that now to help us in proofs that go beyond just finding triangles congruent, and we'll see that in a minute. What we also start to do is kind of collect a list of things that show up a lot whenever we talk about proofs. One of them is vertical angles. So if we have 2 triangles that meet to kind of look like a bow tie idea, we're going to have vertical angles are congruent. Reflexive property is also another common one. When 2 sides are shared, when one side is shared in 2 triangles, we say it's congruent to itself by reflexive property. So that could look like this pointy football here. It could be the overlapping side that's shared down here, or something even as angle, an angle that is shared in both triangle. That's going to be reflexive property with an angle being congruent to itself or a side being congruent to itself. We also get midpoint bisectors and angle bisectors. Now midpoint and segment bisector are the same idea. So if I have a segment and then I'm told that a point is a midpoint, I know that I could then set those 2 parts, so in this case BA is congruent to CA, and our reason would be definition of a midpoint. If we have an angle, say ABC, and it has a bisector, let's say BD, I would say that angle ABD is congruent to angle CBD. And that's going to be by the definition of an angle bisector. So this idea of taking something, splitting it into 2 congruent parts, and setting them congruent to one another shows up. Anytime we have right angles, now right angles we know equal 90 degrees. If I have 2 angles that equal 90 degrees, I'm going to say that right angles are congruent. Being perpendicular is also connected to that, because if I have perpendicular lines, I have right angles, and right angles are congruent. So we'll see those come up as well. Parallel lines. Now parallel lines aren't congruent themselves, but they lead us to really 2 types of congruent pairs of angles. One is corresponding angles that will typically show up in this pattern where we have parallel lines with a transversal, and the 2 angles would be corresponding in the same location within the 2 triangles. And then alternate interior is our bow tie idea again, but it's those alternate interiors with this transversal. It would also work on the other 2 angles if we went to this corner. We could say that these 2 are also congruent by alternate interior. Alternate interior also applies to when we may have a quadrilateral with one diagonal, and what we're doing there is the Z that is formed by the parallel lines in the transversal guides where the angles show up. So those are really the 2 types of diagrams where alternate interior show up. So with that in mind, let's kind of talk our way through some congruence ideas. So let's start with, we just have a diagram. We need to figure out, is AE congruent to BD? So not a formal proof, but we're just going to talk our way through and see where we're at. So I have A and B congruent, those angles here, and then D and E. If I look, those angles make up 2 sets of triangles, and those are the triangles we're going to use. So that's DAB and EBA. So these are the overlapping triangles with one of them right here, and then the other right here. Now we could do like this left and right side triangles, or maybe triangles that are up on the top, but these are important because they give us values we can work with. So what do I know from this? Well, I also know that AB is congruent to itself. That's going to be by reflexive property. And once I have that, I can say that triangle DAB is congruent to triangle EBA by angle, angle, side. Now once I have those congruent, I can say that AE is congruent to BD because corresponding parts these 2 of congruent triangles, these 2 are congruent. Now that's the informal way of the proofs that we're going to be looking at. So we come down to the bottom left. I have some givens here, which we'll label. And I've already written them here. Now I want to show that AB is congruent to CB. In order to show those are congruent, I have to find that the two triangles are congruent, and that's going to be ABD and CBD. Now, in order for those to be congruent, I have to find the other part to get to the congruence. So if I look, BD is the reflexive side, so that is congruent to itself. So we'll say BD is congruent to BD, and that is reflexive property. Then from there, how are the two triangles congruent? Well, I have two sets of angles and a side. The side is not between the two, so that'll be angle, side congruence. Now that we have congruent triangles, we're going to say the parts are congruent because corresponding parts of congruent triangles are congruent. Next one, we have CN is congruent to WN. Angle C is congruent to angle W, both given. Now, I want RN and ON. RN and ON are these two sides here. They are not on triangle CRO and WOR. They're on the kind of the left side, right-sided triangles that I'm looking at. So I'm going to write those here just to give me something to work with. So that's CNR is congruent to WNO. Now the reason those are going to be congruent is corresponding parts of congruent triangles are congruent. I wrote too many letters there. So what we have to figure out is what's the middle steps that get us triangle congruence, what type of triangle congruence it is, and then we have the rest of the proof filled in. So let's label what else I know. So I have C, angle W were congruent, and then CN, WN were congruent. Well, at angle N, I have vertical angles, so let's put those in there. That'll be angle CNR is congruent to angle WNO, and that's because vertical angles are congruent. And now we need to name our congruence for the two triangles, and it appears two angles and a side. That's going to be angle, side, angle. Once we have that, we can then say that RN is congruent to ON because corresponding parts of congruent triangles are congruent. Next page. I've kind of written the givens already. Let's fill those in. And let's go up to the first one. So I need to figure out which triangles I'm using first. So I have S and I are congruent. I'm just going to put dots because I got a small diagram there. S and I. I have G and A. And then I have T as the midpoint of SI. It should be SI there. Now if T is the midpoint, then that gives us those parts. So it's looking like if I redrew my triangles, I want the triangle GST because then I have this congruence. Let's label some points a little better. Then if I went with the other one, kind of the flipped version of ITA, I also have the same type of parts. So that's what we're going to work with. So I have a midpoint. Midpoint's telling me that IT is congruent to TS, and that is the definition of a midpoint. Next, I need to have, I already have my angles identified. I think I can go triangle congruence. So we're going to show triangle GTS. So that went one dot, no dot, double dot. So I'll go ATI. And this is going to be two angles and a side. The side is not between the angles, so angle, angle, side. And then SG is congruent to IA, which is this side and this side, and that's because corresponding parts of congruent triangles are congruent. Next one, we have MN is congruent to MA, and ME is congruent to MR. Now I'm going to split these up. So let's draw them separately here. We got EMA and NMR. It's going to be a little easier to see once we label. We had our congruent sides here and congruent sides there. Now, kind of planning it out, I need to get something else. I don't know about EA and NR. What I do know is this angle right here was in both of them, this angle M. So this angle is going to be congruent to itself in both triangles. I don't have to technically name with 3 letters because it's the single angle in both. So we're going to say angle M is congruent to angle M by reflexive property. Now we can identify our 2 triangles as congruent. So that would be, let's go EMA is congruent to. So EMA went down the double line, single line. So we'll do RMN. And that will be by side, angle, side. And then we know that angle E is congruent to angle R because corresponding parts of congruent triangles are congruent. Last one, we have BT is congruent to EU, and BU is congruent to ET. So what that means, let's look here. BU and ET, we know those are congruent. We know we have vertical angles. We want angle B and angle E, but this BU, BT, and EU is a problem because that spans both triangles. So what if we drew a side right here? So now we could make 2 triangles, go B, U, T, and U, T, E. We have BU and UE congruent. We have BU and ET congruent. We need, let's get the markings to match. We need something else. Well, that vertical angles didn't show up here. But what if I go UT is congruent to UT? So that would work. UT is congruent to UT, and that is reflexive property. From there, I have 2 congruent triangles. So we'll go triangle BUT is congruent to, let's say we went 1 and 3, so ETU. That would be by side, side, side. And then last, angle B and angle E, which are now corresponding angles here. Corresponding parts of congruent triangles are congruent.